Hello and welcome to today's edition of the program. My name is Terry Makibinosa and today we'll be looking at trigonometry. Although our emphasis will be on cosine and sine rule, but I want us to have an overview of what trigonometry is and how we can apply formulas that relates to trigonometry, which involves sine and cosine rule. Because the sine and cosine rule are not just the main formulas used in trigonometry. There are other formulas. Here we are going to talk about them. But before then, trigonometry actually originates from a combination of two words, tri, which means three, and gonometry, which is gotten from the word geometry. Okay, this is gotten from geometry. And geometry talks about shapes with relation to angles and distances. Okay, we'll just take that abbreviation. So gonometry is gotten from the word geometry, and geometry talks about shapes that has to do with angles and distance. So when we combine these three words, tri, which is three geometry, we will be talking about shapes that has three sides. So we'll talk about trigonometry here. Refers to three-sided shapes. Now, in mathematics, three-sided shapes are usually triangles. So we'll just see this. Let's say we have this down here, and we have this, and probably have this. It is a triangle. So you have side 1, this very part here, side 1, and here you have side 2, and here you have side 3. So trigonometry, as a matter of fact, talks about a triangle, problems involving triangle. Now let's take a look at some of the formulas that are used for solving trigonometry. The first one here we will look at would be the Pythagoras theory. You also have the sine, cosine, tangent functions. So this formula basically is what you call the SOHCAHTOA. And the third one here will be the sine rule, and fourthly you have the cosine rule. So these four formulas are used to solve trigonometry. Meanwhile, the first two here, which is the sine and the sine cosine tangent function, as well as Pythagoras theory, are mainly used to solve right angle triangles. So you use this to solve right angle triangle. And you use these other two formulas to solve non-right angle triangle. So let's take it in plural. So we'll be looking at how these formulas are used to solve triangular problems. Like I said, the Pythagoras theorem and the SOHCAHTOA are only used for solving right angle triangles, while the sine rule and the cosine rule are used for solving non-right angle triangles. So we will begin by looking at the Pythagoras theory. What does this say? Let's take this out quickly. I shall talk about the Pythagoras. Now, if I have a right angle triangle, remember we talked about right angle triangle, this formula used for solving right angle triangle. If I have a right angle triangle, let's say this is my right angle triangle. And by the way, how do I know that this is a right angle triangle? It's simple. Usually, every right angle triangle is indicated with a symbol here that shows that it's 90 degree. So if one of your internal angle in the triangle is 90 degree, then it is a right angle triangle. Now the side that faces that 90 degree usually is called the hypotenuse because it's the longest side. It's called the hypotenuse. Then these other two sides, like here is your y dimension, we'll call here y, and here's our x dimension, we'll call it x. Now let me denote the hypotenuse side with the letter r. Now what Pythagoras theory here says is that r squared, the square of our hypotenuse side, is equal to the sum of the square of other two sides. So it's equal to x squared plus y squared. Now this formula is what we call the Pythagoras theorem. I may just take a highlight here so you see what I'm talking about. So this formula is what you call your Pythagoras theory. The moment you can identify that it's a right angle triangle, then you can either use the Pythagoras theory to solve for that solution, depending on how the question goes, or you use your SOHCAHTOA, which is your cosine, sine, and tangent function. Well, here let's see how do we apply the Pythagoras theory. So we're going to be looking at the condition for applying Pythagoras theory in solving right angle triangles. The first condition here would let's just say it this way. Okay, sorry. I'm going to take that out. Let's say it this way. Conditions for using Pythagoras theory. Number one, it must be a right angle triangle. So the triangle must be a right angle triangle. Then number two, you must have the three sides involved in the question. So we'll just go like let's say I could scroll up a little. It says given any two sides to find the third side. So whenever you're given any two sides of a right angle triangle and you're asked to find the third side, you use your Pythagoras theory. So these are the two conditions. Number one, it has to be a right angle triangle. Number two, you have to be given any two sides to find the third side. Now we'll just go and take some examples here. Here we have an example that says find arrow in the figure below. Now what is this figure we're looking at? We're looking at a triangle of this kind. Let's see. So it is a right angle triangle, and here we're asked to look for arrow, and here is given as 3 centimeter, and here is given as 6 centimeter. Let's see. Remember, it is a right angle triangle. Usually they used to indicate this symbol here to show that it's a right angle triangle. So what we are looking for is the hypotenuse. We can just quickly identify. Hypotenuse side is equal to arrow. The x dimension side is equal to 3. And the y dimension side, the x dimension side is equal to 6 because we're looking at the horizontal dimension, which is 6. So we'll take this one off and correct that. so it's 6, and the y dimension is 3. And our formula says arrow, which is the hypotenuse square, is equal to x dimension square plus y dimension square. And if we apply this formula, we're going to get arrow square. We remember arrow is r, so we'll just go here, is equal to x dimension, which is 6 square plus 3 square, and that will be arrow square is equal to 6 times 6 is 36 plus 9. So we have arrow square is equal to 36 plus 9 will give us 45. So if I want to find this, if I square both sides, if I find the square root of both sides, this square will take care of the square root here, and my arrow here will be equal to square root of 45. So I have arrow to be, let's see what I'm going to have as the square root of 45 would be 6.71. So we have 6.71 centimeter, which is the value of your arrow. Another question says find the value of P in the figure below. You have a right angle triangle here. How did we know it's a right angle triangle? Usually there is this mark indicated, so you should always take note of that. That shows that these two lines are perpendicular, which means they are at 90 degrees. So now we are identifying that it's a right angle triangle. Fine. What do we need to find? P. We are given two sides to find the third side. Then we can use the Pythagoras theory. Remember, we said the condition for using Pythagoras theory is that you must have a right angle triangle and must be given two sides to find the third side. So now let's see. Our arrow here in this case, which is the hypotenuse side, is 8 centimeter. Our x dimension is what we are looking for, P. Our y dimension is 6 centimeter. That's the y dimension here. So if I apply our formula, which says arrow square is equal to x square plus y square. I'm actually looking for x. Then if I make x the subject of the formula, rather x square is the subject of the formula, we'll have x square is equal to arrow square minus y square. Try it out. Anytime you're looking for any of this other side that is not the hypotenuse side, you always have your hypotenuse minus the other side. You can check that out and see how I got that. Now we are going to substitute our formula here and say P square is equal to 8 square minus 6 square, and that will be P square is equal to 64 minus 36. So I'll have my P square is equal to 64 minus 36. If I punch that calculator, I'm getting 28. And here I have P square is equal to 28. Yes, that's it. But if I find the square root of both sides, remember, whatever you do to one side of the equation, these are two sides. Whatever you do to one side of the equation, you can do to the other side, so that my square root can take care of this square. And now I'm having my P to be equal to square root of 28. Now we don't really have much space, so I'll just find the final answer here. P will be equal to, let's see, what's the square root of 28? If I check that out, I have 28 square roots, which is 5.29. So I have 5.29 as my final answer. So this is what you have as the value of P. Now we can take another example here. The second question here says a cone has height 18 centimeter and slant height 25 centimeter. Calculate the diameter. Now we have to know what the cone looks like first. This is what the cone looks like. Then we are actually talking about this part representing slant height, and that is it over here. This is what the cone look like, and if we are looking at the dimension we are given here, we are given the height, which is represented by this very tiny line here. The height is usually a straight vertical dimension taken, and we're looking at the diameter, which is the whole of this from this part to this part. That represents the diameter. But as a matter of fact, radius is half of the diameter. So the radius is what we are going to work with. We're going to work with this radius here, which is half of the diameter. So that makes us have a thing of this form. Alright, then let me just quickly outline the sides given here. You are given this land height to be 25 centimeters. So we have here as 25 cm. You are given the height as 18 cm. The radius here we don't know, so we'll just represent it by a big arrow. Now the thing here is this: what we are actually having is a thing of this kind. We're having a triangle of this manner. Now we'll see whether it's a right angle triangle or not. Let's see. So this is what we are having basically, and we have here to be 25 cm, we have here to be 18 cm, and we have here to be big R. Now it is a right angle triangle. Why? Because if you look at this height here, it is perpendicular to the radius, so that makes it a right angle triangle. Perpendicular means it's at 90 degrees. Now we have been able to establish that it is a right angle triangle. What next? What formula are we going to use? Here we have two sides to find the third side. Remember, that's the only case where you have to use your Pythagoras theory. So I'll just go using my Pythagoras theory here. My arrow, usually which represents my hypotenuse, is given as 25 cm. My x dimension is given as capital letter R, that's what I'm looking for though. And my y dimension is 18 centimeter. So if I apply the formula which says arrow square is equal to x square plus y square, and what I'm actually looking for is this very value here, x square. Sorry, I have to cycle it that way. So what I'll do is to make that the subject of the formula, and I'll have x square is equal to arrow square minus y square. Now I'll begin to substitute my value here. I have arrow square, which is representing your x dimension, is equal to 25. So you have 25 square minus 18 square, which is represented as for y. So here I'm going to have arrow square is equal to, my 25 square will give me, if I punch my calculator, 625 minus 18 square, which is 324. So at the end of the day, I'm having arrow square is equal to, when I subtract this from this, 324 from 625, I'll be left with 301. So that will be 301. Now arrow square is equal to 301. That makes me have, if I take square root of this so that the square root can take care of the square, I have to take square root of the 301 as well. Remember, what you do to your right hand side, you do to your left hand side also. So you have arrow to be square root of 301, and that will be equal to 17.35 as your final answer. So the value of arrow is 17.35, which is the radius, but that's not all we are asked to look for. They said we should look for the diameter. And remember, I said diameter is 2 times radius. So I could just indicate here my diameter is equal to 2 times radius, big arrow. So that would be 2 times 17.35, and I'll have that to be equal to, let's see, 34.70. That is my final answer. So this second example here says you have a right angle triangle. How did we know that this mark ought to be given? So you have a right angle triangle here. This angle, one of the internal angle here, is given as 30 degree. Then you have x and the opposite side of the angle is given as 11.7. So we'll just quickly identify the sides here. This side that is facing the angle, remember I said is the opposite. Anytime you're having an internal angle other than 90 degree, the side that faces it is the opposite. So we have OPP is 11.7 centimeter. The other side, which is not the longest, remember this is the longest side, that's the hypotenuse. It's not given the question, so we have nothing to do with the hypotenuse. The adjacent ADJ is x in this case. Theta is given as 30 degree. Now remember this formula says so car toi. Now so refers to, as they talk about sine theta is equal to O for opposite over H for hypotenuse. So this is the formula. Sine theta is equal to opposite over hypotenuse. And for cosine here you have car, which is C stands for cosine. So you have cosine theta is equal to adjacent over H hypotenuse. Then for toi you have T stands for tangent. Tan theta is equal to O for opposite and A for adjacent. So here we have a formula that says sine theta is equal to opposite over hypotenuse, cosine theta is equal to adjacent over hypotenuse, and tan theta is equal to opposite over adjacent. So if I apply this now, which of the formula am I going to use? Here I'm having opposite, I'm having adjacent, and I'm having theta. So which of the function am I going to use? Opposite and adjacent is this formula here. So I'll just take note of this very formula. This is the one I'm picking out. So the others will leave. Now I'll quickly show that. So in this case we are using tan theta is equal to opposite over adjacent, and that will be tan 30 degree is equal to opposite is 11.7 centimeter over adjacent, which is x. Now I'm looking for my adjacent, and this is a fraction. Adjacent is actually the denominator of this fraction. I can make this a fraction by cutting it over 1, then cross multiply. So I'll have x times tan 30 degree is equal to 1 times 11.7 cm. If I divide both sides by tan 30 degree, and I also divide here by tan 30 degree, you find that this will cancel out this. So I have my x to be equal to 1 times 11.7 over tan 30 degree. This is equal to 11.7 over 0.5774. And let's see what my final answer will yield. So finally, I'm having x here to be equal to 20.26. So this is my final answer. Because there's no space here, I have to quickly come and write it here. This question says an angle of elevation of the top of a tree 6.4 meter tall from the point on the horizontal ground is 280 degree. Calculate how far is the point from the top of the tree. Okay. Let's see. This is the tree. This is the diagram here to represent a tree. Of course, tree stands erect. So we'll say that's the tree. And this is the base of the tree. It has there's a point on the same horizontal ground. So this very point here is what we're looking at. So the angle of elevation from that point to the top of the tree. So this point to the top of the tree, the angle of elevation we talks about this angle here is 28 degree. The tree is 6.4 meter tall, so this is 6.4 meter. This is the point P, this is the bottom of the tree, and this is the top of the tree. And they say calculate how far is the point, how far is this point from the top of the tree from here. So we're looking at this part X. We don't know, so we'll call it X. Let's see. Here we have an angle, two sides involved, and anytime we have an angle and two sides involved, remember we're using the sine and cosine formula. Remember, this is a right angle triangle. Why? Because the tree is standing erect perpendicularly to the ground, so it makes it 90 degree here. And we can just quickly identify this. Theta is what? 28 here. The opposite, OPP, is the opposite of the angle given, which is 6.4 meters. The hypotenuse, HYP, is given as X. Now, what's the relation between opposite and hypotenuse? We'll be looking at sine. We'll say sine theta, so is equal to opposite over hypotenuse. So that becomes sine 28 degree is equal to opposite, which is 6.4 over hypotenuse, which is not known, so we'll call it X. Now for us to find X, we can make this over 1, so that becomes fraction, and we'll cross multiply. And here we'll be having X times sine 28 degree is equal to 1 times 6.4. And if I divide both sides by sine 28 degree, here also by sine 28 degree, this will cancel out this, so I'll have my X to be equal to 6.4 divided by sine 28 degree. Now we're just quickly going to look that X here will become 6.4. What is sine 28? That will be 28 sine function 0.4695. So we have 0.4695. At the end of the day, when we divide, X will be equal to 13.36. So that's your final answer. This is the value for X. Here you have 13.36 meters. So you can just pick up these examples. They are not difficult. Try and solve as much as you can in your textbook. The next phase we'll be looking at is the sine and cosine rule. These two rules are actually used to solve problems that involve non-right angle triangles. And we'll begin with the sine rule here. Let's see. Sine rule, or what you call the sine formula. The formula says if you have a triangle of this manner, let's see. And this part of the triangle is called A, this other part B, and this part C. The side that faces A will be the small a, and the side that faces B will be the small b. The side that faces C will call the small c. Now the formula says A all over sine big A is equal to B over side big B, which is equal to C over sine big C. So what we are trying to say here is that there's a relationship between the side of a triangle given and the angle of that triangle. This A actually refers to this angle, B refers to this angle, and C refers to this angle. Now, you cannot apply these three relationships at a time. You can either use A and B, or you're using B and C, or you're using A and C. It depends on how the question comes though. So we are going to look at some couple of examples, but before then, let's see where we need to apply our sine rule. So we'll take down the conditions for applying sine rule. Conditions for applying sine rule. The first condition here says the triangle must be a non-right angle triangle. The second condition here says the triangle must be given two sides and one opposite angle to find the other opposite angle. Or two angles and one opposite side to find the other opposite side. So in summary, what we're referring to is that it must involve two angles and two sides. That's what we're saying. Now this is what you do each time you're given a triangle and you're asked to solve using the cosine rule. Well, sometimes you may not be asked to solve using cosine rule. You have to determine whether you're using a cosine rule or not. So the moment you can identify A and small a, then B and small b, or C, okay, here's B rather, the same as this also, and small c. So what we'll do is, this is what helps us determine whether you're using our cosine rule or not. Just look at this diagram. It's a dumbbell shape. So I'm going to see if I'm looking at a question that involves B and small b this way. This is a dumbbell shape. And A and small a this way. Another dumbbell shape. Then I'm actually talking of using the sine rule. The moment you can identify two dumbbell shapes in your triangle, you should be talking about using the sine rule. Let's take an example and see what we are talking about here. This question says, find the value of P in the diagram. And the diagram is given this way, 8 meters, although our sides are not listed. Or I could just take it arbitrarily. Let's say we take here A, we call here B, and we call here C. So what we have is angle A, which is 102, and the side A is referred to as P, and angle C, which is 18 degree, and the side of C is represented by 8 meter. What we will do here is to identify the dumbbell shape if possible, so that we'll know if we're using a cosine or a sine rule. But if we can identify a dumbbell shape in this way, that's one, and this other side has a dumbbell shape with this angle also, that's two, then you know that you're using your sine rule. So it's a 2 by 2 dumbbell, which means 2 angle and 2 sides. So that is exactly what we are having here. Now we can just proceed here to solve. We're using A and C. We have A over sine big A is equal to C over sine big C. From what we have here, small a is given as P. That's what we're looking for. Small c is 8 meter. Big C is 18 degree, and capital A is 102 degree. Now if I apply that to this formula quickly, I'll be looking at this. P over sine 102 is equal to, that's 102 degree, is equal to 8 over sine 18 degree. Now if I'm going to solve for P, I have to make P solve the formula. That means I'll cross multiply here. So I have P is equal to 8 times sine 102 degree divided by sine 18 degree. You can quickly check that out on your own how we got that. So we'll just take this here. 8 times 102 sine function 0.9781. So you have 0.9781 divided by, let's see, 18 sine function 0.3090. 0.3090. At the end of the day, you're having your P to be, let's see if we add up these two. 8 times 0.9781 divided by 0.3090, and that will be equal to, where is my equal to here, 25.32. So I have 25.32. So my P is 25.32 meters. That is what I'm having as P. It's quite a long line. The question here says find the value of A. In this triangle, you have big letter A to be 60 degree and small letter A to be A not given. Big letter B 80 degree and small letter B not given. Once again, we're going to identify if it's a 2 by 2 dumbbell shape. The moment I can take this out, let me see, the first dumbbell, and I still can take the second dumbbell out, which means I'm dealing with the sine rule. So I'll quickly outline it here so that you won't get confused with the dumbbell diagram that I just made there. This is what we are having, and this is it. We were given this angle here to be 60, and the letter representing here is A. Small a is what we're looking for. We're given here to be 80. The letter representing here is B, and this side of B is 5 cm. This is exactly the diagram. So here we are dealing with A and B. We have A, small letter a to be unknown. That's what we're looking for. Small letter b to be 5 cm. Big letter a to be 60 degree, because that refers to the angle. Big letter b to be 80 degree. Remember, there's a comma here, so it doesn't go together. Here I'm just going to apply the formula, and it says a over sine big A is equal to small b over sine big B, and that's what gives me a over sine 60 degree, which is equal to 5 over sine 80 degree. And if I have to find my a, I'll cross multiply. I have a times sine 80 degree is equal to 5 times sine 60 degree. Now let me divide both sides by sine 80 so that I can make a my subject of the formula. Here I'll have a to be equal to 5 times sine 60 degree divided by sine 80 degree. Let me quickly see what I'm going to have. Finally, let me remove this dumbbell shape here. Okay, you can do the remaining ones here. So this is what I'm having. I'm having a is equal to 5 times, let's see what sine 60 will give. Let's punch our calculator here. 60 sine function 8660, so you have 0.8660 divided by, what is sine 80? Let's see this. 80 degree sine function 9848. So we have 0.9848. Then my a finally will be, let's multiply all this out and see. We have, first we have 5 times 0.8660. Let me pull this out so that I can see what I'm doing here. Divide by 0.9848, which is equal to 4.396, which is approximately 4.4. So I have 4.4 centimeter as the value of a. So this is my final answer here. You can just pick up some examples in your textbooks and you solve as many as you can. The moment you can establish a two dumbbell shape diagram from what you have in your triangle, then you'll be able to know whether you're using your sine rule or your cosine rule. The next one here we'll be talking about is the cosine rule. And this rule is also applied to non-right angle triangle, but it's much different from the sine rule. The rule says that if I have a B and C in this way. This side is called small a, small b, and small c. Remember that if I'm looking for a, the formula says a square is equal to b square plus c square minus 2bc cos capital letter A. And if I'm looking for b square, I'll have it as a square plus c square minus 2ac cos b. And if I'm looking for c square, to be a square plus b square minus 2ab cos big C. Now this is used for solving sides, and each time you want to solve for your angle, you make the angle part the subject of the formula. So you're going to have cos A is equal to b square plus c square minus a square all over 2bc, or you have cos b is equal to a square plus c square minus b square all over 2ac. And here if I'm looking at cos c is equal to a square plus b square minus c square all over 2ab. Now you can see that whenever you're looking for the side A, you have two other sides given and the angle that faces A, that's the angle of A. So there's a relationship here. You just have to take a very good look at that. Whenever you're looking for A, you must be given cos A and two other side. This is what we have here. And whenever you're looking for B, you must be given two other side, A and C, and the angle B. So you study this relationship very well. Now if you're looking for the angle, you just have the three sides here involved. So you must be given 1, 2, and 3. You must be given the three sides for you to be able to solve for the angle. Now we'll take a look at this proper when we visit some examples. Before then, let's look at some conditions for applying the cosine rule. We have cosine rule here. Conditions for applying the cosine rule. Conditions for applying the cosine rule formula. Let me just highlight this so that we should know what we are talking about here. It's all about the cosine rule. So the conditions for applying the cosine rule here would be 1. The triangle must be a non-right angle. 2. The question must involve three sides and an angle. So the question must involve three sides and an angle. Here we just took the summary of it, but we're going to look at it later. Now for the case of a cosine rule, what you do is if you're having a triangle, you should watch out for this kind of shape. If I have here as A, B, C, and I'm giving small letter B, A, and C. You usually don't have a two dumbbell shape in this case. What you do is you have one dumbbell shape, or the mistake. You have one dumbbell shape and two sides given like this. So you don't always have two dumbbell shapes. You just have one dumbbell shape and two sides like this. So we'll be watching out for this very one. But before then, let's take some examples. So this example says 6 centimeter on this side, 7 and 11.4 on this other side, and you are asked to find the angle alpha. Let's see, we can actually identify the dumbbell shape here. Looking at this, the angle on the side, and these other two sides. You can see that it's a case of a cosine rule. So we'll just go ahead to apply the formula. And it says small letter A is 11.4, B is 7, C is 6 units, and cos, that's capital letter A, is what we are looking for. We're using the formula that says cos A is equal to B square plus C square minus A square over 2BC, and that will be cos A is equal to, let's see here, 7 square plus 6 square minus 11.4 square all over 2 times 7 times 6, that's 2BC, and this will be equal to, we'll say here that cos A will be equal to, let's see, 7 square will give us 49 plus 36 minus 129. Let's see, I can manage the space points. Okay, let me remove that. That space is too small for me to manage. So I'll just take it here. This is equal to 49 times 36 times 129.96 all divided by 2 times 7 times 6. So this whole thing will give us here 49 plus 36 will be 85 minus 129.96 all divided by 2 times 7 times 6 will be 84 here. So here I'm having minus 44.96 all divided by 84. So I might want to solve that further with a lot of space, so I'll just take one of these out. Let me take, okay. Problem here is that I have a very small space I have to manage. So this will just go this way. Here I have my cos A to be equal to minus 44.96 all over 84. Let's see what that would be. Cos A will be equal to, if I punch my calculator, I'm going to get minus 0.5352. So cos A is equal to minus 0.5352. Then A becomes cos inverse of minus 0.5352. Let's see what that will give. A is equal to 122.4 degree. That's my final answer. So the angle of A here is 122.4 degree. So this second question comes in this way, and we're asked to look for x here. Though they did not include the sides, but we can just name it arbitrarily. We can call here A, and here B, and here C. So let's see the kind of dumbbell shape it gives. We have B forming a dumbbell with C. Sorry, you have B forming this dumbbell here, and you have two sides included, with just one dumbbell shape. So we're looking at cosine rule here, and the first thing we'll go ahead to do is to identify the sides. You have small b to be what you're looking for, x, small a to be 8 cm, small c to be 13 cm, and big B to be 49 degree. So let's just see here. It says small b square is equal to a square plus c square minus cos b. So if I use that, I'm going to get x square is equal to, because the side b is represented by the value x, 8 square plus 13 square minus, there's supposed to be minus 2ac here, sorry, 2ac. So you go 2 times 8 times 13 times cos big B, which is 49. So here I'm going to have it as 64 plus, this is my x square. Let's see what this will yield. 13 square, let me take this calculator here. 13 square will be 169 minus 2 times 8 times 13, 2 times 8, sorry, the times 8 times 13, which is equal to 208. So I have 208 times cos 49. Now we'll be looking at what cos 49 is. So we have 49 cosine 6561 approximately. So we have x square is equal to 64 plus 169 minus 208 times 0.6561. Now that becomes x square is equal to this plus this. As a matter of fact, you go using board math, so you do the multiplication sign out first. The whole of this minus 208. Remember, this sign belongs to 208. So you have minus 28 times the whole of this here will give us multiplied by 208, which is equal to, so here I'm having minus 136.46 minus 136.46. Then you bring down this plus this here will give us let's see, 3, 12 plus 1, 3, 2. So this is what we're having, and at the end of the day we could finish up this here. I'll get 3233 minus 136.46, and this is equal to 96.54. 96.54. Now I want to make x sorry the formula. That means I have to take square root of both sides, so that the square here can cancel out this square root, and I have x to be equal to square root of 96.54. Okay, and that will be equal to my final answer. Let's see what we'll get. 96.54 square root 9.83. So our final answer is 9.83, and it's given in cm. So 9.83 cm is the final answer.